Hi guys, welcome back my YouTube channel. I am from Sri Venkateshwara College of Engineering, Bangalore, Department of Information Science and Engineering. My name is Suha.M USN 1VA23 IS 050. Subject Discrete Mathematical Structure. Subject Code PCS 405A. Topic Function Compositions and Inverse Function. In this video, I am going to introduce the subtopic as Introduction of Function Compositions and Inverse Function. In mathematics, functions are like machines that takes an input, do something to it and produce an output. But what happens when we want to use one function after another, or when we want to reverse what a function does? That where function composition and inverse function comes in. Function composition. Function composition is when you combine two functions into one by feeding the output of one function into another. Think of it like stacking two machines. The output of the first goes directly into the second. Inverse function. Inverse function do the opposite of the given function if a function takes you from point A to point B. The reverse takes you back from B to A. Not all functions have inverse, but what they do, the inverse undoes what's the original function. What is function composition? Function composition is a process combining two functions in one by applying one function to result of another. In terms of, if you have two functions like f of x and g of x, then the combination of as written as f of g of x is equals to f of g of x is equals to f x square is equals to 2x. What is inverse function? An inverse function reverses the effect of original function. If a function takes an input and gives an output, then it is reverse takes as gives back the original x. Where we use function composition and its applications. Composition of functions. In set theory, if you have two functions, f of a is to b and g is equals to b is equals to c, then the composition g of f is equals to a raised to c is defined as g of x is equals to g of f of x. Applications used to build complex transformation from simpler ones, which is essential in state machines. Input processing functions. Cryptographical algorithms, chaining, encryption and hashing algorithms, multi-steps data transformation. In relations, if R is a relation from A to B and S is from B to C, then the composition of relations S of R is relation from A to C. A comma C is S of R if there exists B such that A comma B R and B comma C S. Applications, modeling multi-steps connections in graph theory to represent path of length 2. In logic and predict calculus, function composition helps when we predicted predicts and quantifiers over functions. Example, if p is a predicted and f of is a p of f of x is a composition. Applications for function composition, modeling multi-steps processes, chaining functions, simplifying complex operation by combining function, defining recursive function or iterative procedures, building translation functions in automated theory, transforming data structures step by step, analyzing algorithms behavior via stepwise transformation, constructing permutations through function combination. When we use inverse function, in discrete mathematics, we use inverse function primarily when dealing with bijection one-to-one and onto functions. Here is why we use them. Function reversibility. If a function is bijective, then it has a inverse function. This is useful when we want to retrieve the original input from the output, solving equations or problems. In combinators or number theory, we often use inverse function to solve for variables. Counting and mapping. In counting problems involving one-to-one corresponds, knowing the inverse helps understand how or one set relates back to another. Cryptography. In modular arithmetic, common in cryptography, inverse function are used to describe messages. Matrix function. By linear algebra applications in discrete maths, the inverse of a function serves as an inverse function in solving systems. Applications of an inverse function. Decrypting messages in cryptography using modular inverse, reserving bijective functions to retrieve original inputs, solving equation where outputs are known, mapping between sets using one-to-one corresponding, undoing transformation in algorithms or combinators, working with matrix inverse in discrete linear algebra, building inverse relation in relational theory. Thank you for watching my video. Do like, subscribe my channel.